Afternoon, class. Okay. Before I start the lecture for today, I'll entertain first questions, no, and then I'm going to clarify something that I said last time, no. So first, are there any questions from anyone? You can shout it out, or you can send it to me through the chat box. Any questions whatsoever? Wala. Okay. This is where we left off last time. Yeah, might be a question. Okay, there's a question, no? Yung week 1 about basic circuit laws and blocks lang. Yes, that's right, no? It's only an basic circuit laws and blocks. Then next week we're going to start with circuit analysis techniques. Okay, so this is where we left off. But before we continue with the subject matter, there's something that I want to clarify, no? Sorry. There's something that I want to clarify. Okay, we talked about last meeting we talked about I, and I said that I is equal to dq by dt. If it's non-time varying, if I is non-time varying, I is equal to q over t. So this is time varying, and this is non-time varying. Okay. Kailan nagiging non-time varying ang I? Ang I nagiging non-time varying if we take a look at the plot of Q versus T, it is linear. This is where I made a mistake last time. No? Last time pinakita ko yata na flat na ganun. Ano? So if you take a look at the plot of Q versus T, it is linear. And I is the slope of this line. No? I is the slope of that line. No? In general, the relationship between Q and T may not be linear. No? So in general, if you take a look at Q versus T, it might not be linear. No? It might have a strange curve. So when this is the case, our I depends on the actual value of T. For example, at this value of T, let's call this T1, what is I? I is the slope of the line. No? So I, you call it an instantaneous value of I is equal to the slope at this point. No? At this point. That is I. Okay? So this is the case where you get a constant I, and this is the case where you get a time varying I. Okay? For this particular case, what is the average value of I? No? So sometimes that's asked. No? Sorry. Okay. So let's say you have I versus T. So let's say your I is time varying. So what is the average value of I from, let's say you have 2 points, T1 to T2. Okay? So anong average value ng I from T1 to T2? Okay, how do you do that? What you do is you get this area, you get this area, and your I average is equal to your area divided by T2 minus T1. But what is this area? This area is actually the integral of I dt. This is from T1 to T2. So you should recognize that the integral of I with respect to time is equal to Q, which follows, no? Because if I is equal to dq dt, then Q is equal to the integral of I by dt. So that is just this area. Okay? So that's what I wanted to clarify with respect to current. Are there any questions? With voltage, it's quite similar with voltage. How did we define voltage? We said V, this is small letter V, this is dW by dQ. Because what is voltage? Voltage is a potential difference. It's the amount of work that has to be done to move a charge between 2 points. No? In this case, our charge is a differential charge, and this is a differential amount of work. No? Amount of work. No? Now, if you get V, if V is not time varying, then V is just equal to W over Q. No, if V is not time varying. No? So here V is time varying. When does V become not time varying? V becomes not time varying if I show W over Q if the relationship is linear. But in general, so this is V is not time varying. No? In which case, your voltage is the slope. But in general, it's possible for W, the relationship between W and Q to be something like that. And therefore, your voltage will depend on a particular point. No? So here, V is equal to dW by dQ. Okay. Yeah. That's all. That's all I wanted to say at this point. No. No. So there's a question here. No. If the graph is linear or constant, that is when it is time varying. If the graph is linear, if the graph of W versus Q is linear, then voltage is not time varying. Okay, that's what I wanted to point out. If the graph of W versus Q is non-linear, is linear, then the voltage is not time varying because voltage is your slope, and your slope is constant. I hope that answers your question. Similar to current, no? If the relationship between charge and time is linear, then your current is not time varying. What do you mean by the current not being time varying? No? If you imagine your charge flowing, ibig sabihin yung daloy ng charge mo tuloy-tuloy lang at a steady pace. Right? so that with time, the total amount of charge just accumulates linearly. No? That's how you try to imagine it. No? Kung may charge na dumadaloy, steady lang siya. No? Hindi siya pabago-bago, hindi pa bugso-bugso. Steady lang siya. And therefore, pag binilang mo, ilan yung charges nung dumadaan sa isang cross-section at any given time, it's very uniform. Or another way of looking at it is, if you think of your charges as cars on a road, ano ibig sabihin ng non-time varying? No? Ibig sabihin, yung mga kotse mo, pare-pareho lang yung mga speed. No? Hindi pabilis, pabagal, pabilis, pabagal. No? And therefore, if you count the number of cars per second that passes a cross-sectional area, those number of cars will be very uniform, no, over time. Any questions? Don't be ashamed to shout out, no, if you have any questions. Okay, so let's move on. No? Tama, 1:15. I said I'd start the lecture at 1:15. So this is the continuation of last Tuesday's lecture. Okay, our interest in electrical circuits is the ability of the circuits to do work. So when we talk about work, we talk about two possible quantities. No, we talk about power. Okay, we talk about power and we also talk about energy. Okay. Now, power is the rate at which work is being done. So the expression for power is equal to dW by dt. This is the rate at which work is being done. Power is specified in watts. Energy is the total amount of work done. And energy in the SI units is specified as joules. Now remember that dW dQ, okay, well, first of all, dW dt, that's equal to dW dQ multiplied by dQ dt. So remember, this is V and this is I, and therefore power is just the product of voltage and current. The product of voltage and current is power. Okay. So again, the units is watts. Okay, here's an example. No? A car battery has a rating stated in ampere hours that permits you to estimate the length of time a fully charged battery could deliver any particular current before discharge. Siguro sanay na kayo dito sa term na, well, baka hindi kayo sanay sa ampere hours, no? Siguro sanay kayo sa milliampere hours. Kasi kung meron kayong, let's see, I'm sure a lot of you have yung mga charge, ang tawag doon? No? Yung mga pang-charge ng cellphone nyo pag naubusan kayo. Mga charging banks, no? Charging stations. Yeah, power banks, yeah. Thank you for that, Sophia. Power banks. Ano yung specification ng power bank pag binili niyo yung power bank, no? Usually ang sinasabi ng dealer is, sabi natin 1,000 milliampere hours. 1,000 milliampere hours. This is a very common way of specifying a battery. No? What does this mean? This means that it can deliver 1,000 milliamperes for 1 hour. No? Or if you're delivering 500 milliamperes, you can deliver it for 2 hours. So 1 hour, you can deliver 1,000 MA. If you use it for 2 hours, you can only deliver 500 MA and so forth. No? Yun yung ibig sabihin. So yung baterya ng kotse ganun din, no? Although battery ng kotse usually it's ampere hours. Okay. Now, approximately how much energy is stored in a 50 ampere hour? So this is a 50 ampere hour 12 volt battery. So that's typical. Yung baterya ng kotse mga 50 ampere hours, no? Pag malaki yung kotse, a little bit higher. Okay. What is the solution? Well, remember that amperes is coulombs per second. No? Let's see. Yeah, amperes is coulombs per second. No? Amperes times volts is equal to watts. So if I get this and this, no, 50 amperes times 12 volts, so 12 volts is the voltage of the battery, that's equal to watts. That's equal to 600 watts multiplied by H. Kasi 50 ampere hours, no? Multiplied by H. But watts is, sorry, wala palang significance tong coulombs per second. No? Watts is equal to joules per second. So joules per second multiplied by 3,600 seconds per hour. This is actually, yeah, will give you ito, no? 2160000 joules. Okay. So that's the amount of energy that a 50 ampere hour 12 volt battery contains. So I think that's easy enough for you to solve. Okay, here's another example. A battery rated at 7.2 volts and 10,000 joules is connected across a light bulb. Assume that the internal resistance of the battery is 0. Further, assume that the resistance of the light bulb is 100 ohms. So letter A, draw the circuit containing the battery and the light bulb and label the terminal variables for each. Letter B, what is the power into the light bulb? Letter C, determine the power into the battery, and so forth. No? Show that the sum of the power into the battery and the power into the light bulb is 0. And how long will the battery last in the circuit? So let's try to do this. Okay, so draw the circuit containing the battery and the light bulb. Dito ko nilang gagawin, ano? I have a special symbol for a battery. This is my symbol for a battery. Okay. The battery has no internal resistance. Right now, don't worry about that. Ano? So in effect, it's an ideal battery. And then it is connected to a light bulb. So let me show the light bulb this way. And the light bulb can be represented by a 100 ohm resistance. Okay. We did not take up Ohm's law yet, ano? Medyo, kung tutuusin, we don't know Ohm's law yet, ano? But okay, your current I that will flow. So just believe me, for the time being, I will be 7.2 over 100. This is amperes. So this is 72. In effect, this is 72 milliamperes. Now, what is the power into the light bulb? The voltage across my light bulb is 7.2 volts. The current is 72 mA. So my power is equal to 7.2 times 72 times 10 to the minus 3. And I'm going to get, let's see. Yeah. I'm going to get 518.4 milliwatts. Now determine the power into the battery. The power into the battery, and this is because of the passive sign convention, which we talked about last time. Your current in the battery is going from, because your current is this way, no? Yung current natin pa ganyan, no? So your current in the battery is going from the negative to the positive. So that is opposite the passive sign convention, which makes sense because a battery is not a passive element. A battery supplies energy. So because of that, the power into the battery will be minus 7.2 times 72 times 10 to the minus 3. So that will be equal to minus 518.4 milliwatts. So if I sum the power associated with the battery and the power associated with the light bulb, the sum is equal to 0. In other words, whatever power generated must be absorbed. No, that's the law of conservation of energy. Power is the rate at which energy is being delivered. Whatever power delivered must also be the power that is absorbed. Okay, the last question is, how long will the battery last in the circuit? You have 10,000 joules. Sorry. You have 10,000 joules. If I divide that by the number of milliwatts, this should give me seconds. Because watts, remember, watts is joules per second. So I'm dividing joules by joules per second. So this is going to give me seconds. So what I'm going to get is 19,290.12 seconds, which is about 5.36 hours. Okay. I think I have a couple of questions here. If we have the power delivered, can we just negate that and use it as the power into the battery? Yes, you can. No, you can, because you know that there's conservation of power. Actually, this illustrates that the total power will be equal to 0. And then somebody's asking, where did the value 10 raised to the negative 3 comes from? Oh, okay, that's because this is milliamperes. So 70, this is 72 times 10 to the minus 3 amperes. No? Sorry if I wasn't clear. That's 72 times 10 to the minus 3 amperes because this is milliamperes. No? Remember, watts is volts times current. Volt should be in V times I. V should be in volts and I should be in amperes. Okay. So this is just the passive sign convention. Another question, would we have to convert milliwatts to watts first? I already specified it as milliwatts here, no? So in effect, this is 10,000 divided by 518.4 times 10 to the minus 3. No? If you compute 10,000 divided by 518.4 times 10 to the minus 3, you're going to get this. No? Yeah, but you're right. No? If you wanted it to be correct mathematically, then the denominator should be in watts. No? Bali, itong M na to, imply dito yung 10 to the minus 3. You're right. Okay. Okay, so this is the passive sign convention that we talked about earlier. So the basis of the passive sign convention is that a passive element absorbs energy. So if it absorbs energy, that means the charges, as it enters, will lose energy. So ito yung flow ng current. So ito yung mga charges, no? And current is always considered the flow of positive charges. As your charge is flowing, the charge loses energy. And therefore, this is higher potential. And then this is lower potential. So you imagine it that way. Habang meron akong element, habang dumadaan yung charges doon, the charges are losing energy. No? That energy is being absorbed by the element. And therefore, pagpasok ng charge, mas mataas yung potential niya. Paglabas ng charge, mas mababa yung potential niya. So in this case, your power should be positive. If the current is flowing in this direction, and this is lower potential, and this is higher potential, anong ibig sabihin nun, no? Ibig sabihin, habang dumadaan yung current mo dun sa element, it is gaining energy. Saan nanggagaling yung energy na yun? No? How can my charges gain energy as it passes through an element? Well, that means the element is supplying my charges energy. What is an example of that? A battery, for example, can supply energy to electrons or can supply energy to positive charges. So in this case, our power should be negative V times I. Okay. Actually, these two cases are similar, and these two cases are similar. So that is the passive sign convention. Okay, so here, if the power is positive, that is P is equal to 0, greater than 0, power is being delivered to the circuit inside the box. If the power is negative, power is being extracted from the circuit inside the box. No? So compute the power absorbed by each part in the following. So very quickly, no? Chat na lang nyo, type nyo sa chat. What is the power associated with A, letter A? Is it absorbing or is it delivering? Is the element absorbing or delivering? Absorbing. That's right, no? So correct, absorbing. Dito sa B. Absorbing, delivering. Okay? Hindi ko alam kung yung sinasagot nyo is for A or for B, no? But B, it's also absorbing, no? It's also absorbing. No? Absorbing din dito. Kasi ito, ganun din, ano? Yung actual direction ng current, because the current is negative, the actual direction is out of this terminal or into this terminal, no? So this is the actual direction. And the actual polarity of the voltage is, ito yung positive talaga, at saka ito yung negative dahil your voltage is negative. So actually, this is exactly the same as this. And dito, obviously, it's different, no? Dito naman, this element is delivering power. It's not absorbing power. So that's just what this next slide says, no? So absorbing, and delivering. So again, what's an example of an element that can deliver power? A charger, for example, no? A charger. Okay, this is just a circuit analogy. Just to allow you to imagine what a circuit is. A circuit essentially is it's a path or an interconnection of paths where currents flow. No? In essence, pag wala kang current na dumadaloy, you don't really consider it to be a circuit. No? It's a circuit if current is flowing. So this is an example of a very, very simple circuit where you have a voltage source. Here it's called an EMF, electromotive force, but that's actually a voltage source. You have an element connected across the voltage source, and the current will flow this way. No? This element is assumed to be a passive element, and therefore, the potential at this point will be higher than the potential at this point. No? This is another way of specifying potential rise. No? Ibig sabihin itong arrow na to, it's a potential rise. The direction of the arrow is the direction of lower to higher potential. We can make a water-based analogy. So this is the water-based analogy. Ano yung katumbas ng battery? Katumbas niya pump. Anong ginagawa ng pump? Habang dumadaan yung tubig sa pump, the pump transfers energy to the water so that the water will tend to flow faster. So the pump gives the push that allows the water to flow here. Now, sometimes the water will encounter some resistance. So we're going to take that up later on. You know? But the water will encounter some resistance. For example, nagko-constrict yung tubo, lumiliit. Kapag nag-constrict yung tubo, yung flow mo pareho pa rin. No? Whatever the flow is here, it will still be the flow here. No? So the flow will be uniform everywhere. Hindi dahil nag-constrict yung tubo, ibig sabihin mas mabagal na yung flow rito, no? Because there has to be a steady flow. So what happens is, okay, your water is flowing here at a certain speed. Because this is constricted, it will flow faster here, but the total flow will be the same. And then when it comes out here, it will continue to flow again at the normal speed, no? That's what happens. So that's the analogy. Okay. I have a question. What will happen if I put another element here, but it's not connected to anything? Is there current that's going to flow here? Yeah. Bakit wala? No? So this is the direction your current will flow, no? This is the direction your current will flow. So my question is, meron bang current na pupunta dito? Okay? None, no? There's no current that will flow there. We call this a hanging, this is what we call a hanging circuit. Now, why won't there current flow there, no? Because current has to have a path to flow. Pag wala siyang path na dadaanan, then hindi yung charge, ano? Yung charge, kung papasok doon sa element na yon, kailangan may lalabasan siya na path, ano? Kung wala siyang path na madadaanan, hindi siya papasok doon sa element na yon, no? So the current will not enter this element because there's no path. No. In other words, what if this current, what will happen if, for example, there was a current flowing here? Ang ibig sabihin nito, charges are accumulating in this element. And we know that charges cannot accumulate. That was one of the assumptions that I mentioned when we were discussing the assumptions of circuit analysis. The charges cannot accumulate in any particular element or at any particular point. No? Whatever charge going in has to come out. It cannot accumulate. No? So since charges cannot accumulate, we know that there's no current that can flow there. No? So kailangan isara natin yung path so that there's current that will flow. No? So ngayon, magkakaroon ka na ng current dyan. Okay, let's talk about voltage. Voltage, remember I mentioned voltage is also called potential difference. Okay, voltage is also called potential difference. Okay, so voltage is always with respect to 2 points. Now, sometimes we want to have a common reference point for all the voltages in a circuit. So that common reference point, we call that the zero potential point. Or sometimes we call it the ground. So pag nakita nyo itong symbol na to, this is a common reference for all voltages. So what are the different ways of representing voltage? The notes show 2 ways, but I'm going to add a third way. No? So this is one way. So what are our voltages here? Voltages are VA, VB. Those are our voltages. Okay, VA and VB. No? Now we show the polarity of that particular voltage. No? So VA, we know that VA, no, actually medyo hindi masyado maganda yung slide, ano? But let me do it this way. VA is the voltage between this point and this point, and then we show our assumed polarity, that the top is positive with respect to the bottom. And VB is the voltage between this point here, and this point here, that's VB. And again, we show our assumed polarity. No? So that's one way of representing voltage. Pakita nyo yung voltage, and then pakita nyo kung from what point to what point, and then kung ano yung assumed polarity ninyo, no? Which is positive and which is negative. Now, this is another way. No? Ito, what we call this voltage at a node, no? Or voltage at a point. Voltage at a point. No? Teka, akala ko ba sabi natin there's no such thing as a voltage at a point? Well, the voltage at a point will always be with respect to the reference. Okay, so I'm saying that the voltage here is VC, the voltage at this point is VC, but that is with respect to this reference. The voltage at this point is VD, but that is with respect to this reference. Now, we're not showing any polarity here. We're assuming that the voltage at that point is positive with respect to the reference. Yun yung usual convention. No? So this is assumed positive with respect to the reference. Okay, so these are two ways, no? Again, here we show from what point to what point, and then we show the polarity. No? Here, we show the reference. So often, lalagyan natin ng symbol na ganyan just to emphasize that that's a reference. And then this is the voltage with respect to this, and this is the voltage with respect to this. Now, there's still a third way, I think. Is there a question? Yeah, that's right. No, is this the same point? Yes, this is the same point. No, in circuit analysis. Okay, I'll mention this again later. No, a wire can be compressed into a single point without affecting the behavior of the circuit. Okay, so in effect, I can redraw this, no? How do I redraw this? Dito ko na lang i-draw, no? I could have drawn this way. Ganyan. I could have redrawn it this way, no? Like this. Okay, where this is VC, and this point is VD, and this is your 0 volt. So what I'm saying is this and this behave exactly the same manner. If you have a wire, you can compress it into a single point. Actually, the opposite is also true. If you have a wire, you can stretch it. You can stretch the wire. Or if you have a point, rather, if you have a point, you can stretch that point into a wire without affecting the behavior of the circuit. No? Those are concepts of circuit topology. Okay, let me go to the third method of representing voltage, which I said I would talk about, and this is double subscript notation. Sorry. This is what we call double subscript notation. I think this should have been part of the notes. Pasensya na, no? These notes were developed not by me, no. So the same circuit that we had earlier. Okay. Let's say I call this A. Let's say I call this B. Let's say I call this let's just call it O. No, that's my reference. Okay. If I say VAB, this is the double subscript notation. This implies the voltage between A and B, with A assumed to be positive with respect to B. So VBO, again, no, this is voltage between, basically ito yung VBO, no? VBO. No? Basically ito yung VAB. That's VAB. But I don't have to, actually I don't have to write it here, no? Basta sinabi ko yung VAB, alam na natin that this is what it is. If I say VBO, alam na natin that this is what it is without having to draw it there. Okay? So that is what we call double subscript notation. So this is voltage between B and O, with B positive with respect to O. Yeah, there's a question here, no? Why can we compress a wire? That the assumption there is the wire is a perfect conductor and therefore it has no resistance. That's correct, no? So if it has no resistance, then it doesn't matter how long it is or how short it is, or even if it becomes a point. Okay. So let's go to Ohm's law. No? Ito yung sinasabi kong hindi pa natin kinukuha pero it's already needed in the solution of a previous problem. No? The current flowing in a conductor is directly proportional to the applied voltage V and inversely proportional to its resistance R. Okay. So we're talking here about a parameter which we call resistance R. Resistance. Okay. Ano yung resistance? Literally, ang ibig sabihin ng resistance is the tendency of an element to resist the flow of charges. So parang meron kang charge that flows this way. Okay, this is your charge. And ang ginagawa ng resistance, parang pinipigil niya, no? Parang pinapahirapan niya yung charge na dumaloy. So in effect, that is what resistance is. Okay, it's the tendency of an element to resist the flow of charges. We were talking about wire, no? So this is a piece of wire. Okay, you have charges that flow here. Ideally, a wire has no resistance, or ideally a conductor has no resistance. In other words, it will not impede in any way the flow of charge. Tuloy-tuloy lang yung charge. Parang wala siyang resistance. Okay? But in effect, or in reality, the wire has a small resistance. It will try to resist the flow of charge. You might think of it like maybe an analogy. Kung ang laman nito is air, let's say this is a tube with air, then your charge can flow very freely. But if the tube is filled with water, then your charge cannot flow as freely. No? Mas mahirap padaanin yung charge, no? Kung puno siya ng tubig. No? So we say that the latter case, mas mataas yung resistance. Okay, so you have a voltage VAB. Again, I'm using double subscript notation. So ang implication nito is the A terminal is positive with respect to the B terminal. So you have a voltage VAB, you have a current. Let me erase some of the things that are here. No? okay, you have a current that will flow, IR. No? Note that this is the passive sign convention. If this is plus minus, then that means that your charges are losing energy as it passes through, and therefore dapat ganito yung flow ng current natin. So sinasabi lang ng Ohm's law is V is equal to, okay, in this case, VAB is equal to IR times R. No? So actually, V is equal to IR. Yun lang ang sinasabi ng Ohm's law. So the voltage across the element or the resistance is proportional to the current that flows through that resistance. No? I will just be V over R, or R will just be V over I. No? Sometimes they show this triangle, V equal to IR. So it just says that V over I is equal to R, I times R is equal to V, or V over R is equal to I. No? So yun lang yung ibig sabihin ng triangle na yan. So what happens to the energy that the resistor absorbs? It is usually, it manifests itself in the form of heat. So kung ano man yung energy na nawawala nung charge as it flows to your resistor just gets hot. So I mentioned already the voltage across it is directly proportional to the current through it. Ohm's, you call V equal to IR Ohm's law. R is the constant of proportionality. The unit for R is ohms. Ohms. The symbol for R is the omega symbol, the Greek symbol omega. And a resistor is a physical device whose principal electrical characteristic is resistance. In this course, we're going to deal with constant resistances. In other words, we're going to deal with resistors whose value does not change with voltage or current. No? So R is assumed to be independent of V or I. Yung value niya hindi magbabago with voltage or with current. If we're talking about power, power is equal to, what is this question? I don't understand. Ano yung LED na sinasabi? Is this LED? Can John sorry, no? Hindi ko masyadong naintindihan. Can John speak up kung ano yung question mo? Maybe you can unmute yourself and ask your question.
Di ba po sinabi niyo dito po sa course na ito wala pong nagdidilang po tayo sa constant na resistance. So wala po yung mga LED, right? So because LED is non-constant po yung resistance as voltage changes po, right? Or,
yeah, that's right. No. If you were to, well, first of all, an LED is not a resistor, no. Hindi
okay po. Yeah.
you cannot properly model an LED as a resistor because it's not a resistor. It has a different it has a different characteristic, no.
Thanks po, sir.
But if you wanted to model it as a resistor, then it would be, you're right, it would be like a resistor whose resistance changes with voltage or current. If you wanted to, no.
Okay po, sir. Thanks po, sir.
Okay. Sige, thank you. Thank you also for asking the question. Saan na ba tayo? Okay. So power is just voltage times current, but since voltage is equal to I times R, then power is equal to I squared R. On the other hand, since current is equal to V over R, power is also V squared over R. No? So if you know the current flowing through a resistor, you just I squared R, that's your power. If you know the voltage across a resistor, V squared over R, that's your power. No? Now, I'm going to introduce another term. We call it conductance. Conductance is the reciprocal of resistance. Ano yung sinabi ko kanina, no? Ano yung resistor? Resistance is the tendency of an element to try to resist current flow. Yung conductance, yun yung opposite. It's how well an element supports current flow. So kung mataas yung conductance mo, ibig sabihin hindi niya pinipigil yung current flow, no? So conductance is just the reciprocal of resistance, and the unit for conductance is the SI unit is Siemens S. No? But one popular unit that is used for resistance is mho. Saan galing yung mho? Yun yung baliktad ng ohm. No? Mho. And yung symbol is the inverted ohm sign. So pag nakita niyo itong symbol na to, or pag nakita niyo yung symbol na to, that's valid for conductance. And ang formula natin now is I is equal to G times V. No? Remember that G is equal to 1 over R. No? So this is equivalent to I is equal to V over R. So I think these examples are very easy. If I have what is the difference? Sorry, there's a question. No? What's the difference between Mohs and Siemens? Nothing. They're the same thing. No? Kaya or. No? But the more proper term, the real official term is Siemens. Okay. So find the voltage and power dissipated if you have a resistor of 100 ohms. What is the voltage and power dissipated if the current is 0.5? No? So madali, no? So dito P is just equal to I squared R. No? So this is 0.5 squared times 100. Okay? Ano ba yung 0.5 times 100? 25? Yeah, this is 25 watts. Okay? What is the voltage? The voltage, V is just equal to IR. No? So the voltage is 0.5 times 100, which is 50 volts. Another way of computing power is voltage times current. So your current is 0.5, your voltage is 50, so you're going to get 25 watts. Find the current, conductance, and power if the voltage is 2 volts. So the voltage is 2 volts. Okay, first of all, what is conductance? Your conductance G is equal to 1 over R. So this is 1 over 100. So this is 0.01 Siemens. Gamitin natin yung Siemens or mho, no? 0.01 mho. Okay. I is equal to GV. So ang voltage ko is 2 volts. So this is 0.01 times 2. So I'm going to get 0.02 amperes. Okay, and then P is just VI. So this is, sorry about that. So P is equal to VI, so that is 2 times 0.02, no? Which is equal to 0.04 watts or 40 milliwatts. Okay, so I think madali yan. No? Okay, I'm going to speed up a little because we're running a little bit out of time. Okay, we were talking about circuit elements. So I already discussed the resistor as a circuit element. Another type of circuit element are what we call your sources. These are usually the sources of energy, the sources of power. Your resistor absorbs power, your source delivers power. You have two general classes of sources. You have your voltage source and your current source. So the voltage source is a source of potential difference, basically. Pag sinabi mo voltage source, it's the sense of potential difference. This is the general symbol for your voltage source. Okay. The voltage or the potential difference that your voltage source is delivering need not necessarily be constant with time. That's why pag nakita nyo rito, no, in general, your voltage could be a function of time. And in general, the current could also be a function of time. Now, there's a reference potential here. No? So the reference potential is, the top is positive with respect to the bottom. So this is your general voltage source. Now, if it is a constant voltage source or a DC voltage source, then these are your possibilities. So this is the left side. This is the standard constant voltage source, and this is when we represent the voltage source as a battery. Okay, and then later on, we're going to be studying AC circuits. This is a symbol for your AC source. Now, you might ask, bakit may polarity yung AC source? Bakit may polarity? Well, you always have to have a reference polarity. You know, when we do AC circuit analysis, you have to have a reference polarity because all of the voltages and currents in your circuit would have to be specified with respect to this reference at a given point in time. No? So kahit na AC yung source natin, ibig sabihin nag-alternate yung polarity, at a particular instant in time, no, you have to show the polarity with respect to all other voltages and currents in the circuit. Okay, and then you already know this, no? If the current is in the direction of voltage rise, then the source is supplying energy. It's possible for the current to be opposite this, in which case the source is absorbing energy. What's an example of a source absorbing energy? Pag nagkakarga tayo ng baterya, no, yung baterya ng cellphone nyo, in effect, your cell phone battery is not delivering power, but is absorbing power. So it's possible for the current to be opposite the direction of what should be the direction of current in a voltage source when it is absorbing energy. Okay. Your current source, on the other hand, is a source of current, no? Simply stated. And this is the general representation of a current source. And like I said, for the voltage source, it is possible for your current source not to be constant with time. By the way, no, in an ideal voltage source, I forgot to mention this earlier, the voltage is independent of the load. Okay. In an ideal voltage source, the voltage is independent of the load. If I have a voltage source, okay, and I have a load here, kahit anong value, kahit anong load to, kahit na malaki yung load mo, kahit na maliit yung load mo, this voltage will always stay constant. That is an ideal voltage source. Okay? Is there such a thing as an ideal voltage source? No. Tell you why. What will happen if I do this? Sagutin niyo ako, ha? What will happen if I do that? Ano magiging voltage across the voltage source? Yes, that's right. It's a short circuit. What is the voltage across a short circuit? A short circuit has zero resistance. No? If a short circuit has zero resistance, that means the current, no matter what the current is, the voltage across the short circuit is zero. So the voltage here is zero. The voltage here is zero, but the voltage here is V. So there's a contradiction. There's a contradiction. In other words, we call this an invalid circuit. But what will happen if you actually connect that circuit? Well, don't try it. Because if you do, I think something is going to burn. But in reality, the voltage across your voltage source will drop to 0. Okay, that's why there's no such thing as an ideal voltage source. So same thing with the current source. In an ideal current source, the current is independent of the load. Okay, the voltage across the current source is dependent on the load, no? And the current delivered by the current source is independent of the load. Okay, so ang sinasabi ko rito, yung current source, let's say this is your current source, kahit ano itong load na to, I pa rin yan. That is your ideal current source. Okay. So we go now to the basic circuit laws. So this is something that you are going to hear time in and time out, time and time again in your entire 4 years. Well, you're already in your, in your entire stay in the EEE. There are two basic circuit laws. First is Kirchhoff's current law, and the second is Kirchhoff's voltage law. So we'll start with Kirchhoff's current law. The algebraic sum of all currents directed away from a node is 0. Another way of stating this is the sum of currents into a point equals the sum of currents out of the point. And the reason why this is valid is because of the law of conservation of charge. We cannot have charge accumulating at a point. Okay, now how do we define a node? A node is where two or more connections to elements and sources are made. So to illustrate that, this is an example of a node. Okay, so I have, let's say I have these 4 currents, I1, I2, I3, and I4. I1 and I4 are leaving the node, I2 and I3 are entering the node. If we follow Kirchhoff's current law, the algebraic sum of all currents directed away from a node is 0. Okay. I1 plus I4 plus minus I2 plus minus I3 is equal to 0. Bakit negative tong I2 at saka I3? That is negative because it is not directed away from the node. So ang definition dito, directed away from the node. No? So pag hindi directed away from the node, then you have to make it negative. Yun yung ibig sabihin ng algebraic sum. Okay, of course, we could have said it the other way around. No? We could have said directed toward the node. No? So ang convention could have been the opposite convention. But the usual convention is when it is directed away from the node, we consider it to be positive. When it is going into the node, we consider it to be negative. Now, another way of applying Kirchhoff's voltage law is this: sum of the currents entering is the sum of the currents leaving. So this is this, which is identical to this. So this is a node. This is also a node. Okay, but what is the difference between these two nodes? Itong node sa baba, we only have 2 elements that are connected. Dalawa lang elements na naka-connect dito. If there are only 2 elements connected to a node, we say that those 2 elements are in series. Remember that term, in series. That only happens if there are only 2 elements connected to the node. Now, what is special about elements in series? If I apply Kirchhoff's current law here, I'm just going to get this current entering is equal to this current leaving, or I just have one current flowing. So for all intents and purposes, isang current lang yan na dumadaan, no? A current I. Okay. And that's going to simplify our lives later on when we do circuit analysis. No? Basta may nakikita tayo na in series, alam na natin, basta't in series, it's just the same current that flows through all those elements that are in series. Okay, let's go to Kirchhoff's voltage law. No? By the way, trivia lang to para sa inyo. No? Ang talagang pronunciation ng Kirchhoff, I looked it up somewhere, is Kirchhoff. No? It's just that I feel strange having to say Kirchhoff, so I'm going to pronounce it the way everybody else pronounces it, which is Kirchhoff's. Okay. So Kirchhoff's voltage law, the algebraic sum of the voltage drops taken in a specified direction around a closed path is 0. So there are two key terms here: specified direction, and it has to be around a closed path. And this is because of the law of conservation of energy. Remember, voltage is change in, or voltage is work done. So when you start at one point and you end at the same point, the total work done should be 0. And therefore, the potential differences all along the path, if you add them all up, should be 0. So this is part of the law of conservation of energy. A closed path is called either a loop or a mesh. The difference between a loop and a mesh we're going to study later on. No? But when you say it's a loop, that means you start at one node and then you trace specific elements interconnected until you get back to that particular node. No? So that is your closed path. Okay, ano yung convention natin when we do the algebraic sum? No? If you're going in this direction, so this is the direction of the path, and then your polarity is this way, then your voltage is positive. Okay, so for example here, let's say we're going this direction. This is the path. No, this is not necessarily current. No, not necessarily current, but this is the path. Taking the algebraic sum, okay, we're going from plus to minus, so that's V1. No? We're going from plus to minus, that's V2. We're going from plus to minus, that's V3. And then we're going from minus to plus, so that's minus Vs. That should be equal to 0. And that's equivalent to the sum of the voltage rise is equal to the sum of the voltage drop. Your voltage rises would be V1, V2, and your voltage rise would be Vs because you're going from minus to plus. So that's a voltage rise. And your voltage drops would be V1, V2, and V3. No? So this and this are the same. Okay. So you can use KVL to solve for the unknowns in a single loop circuit. So this is an example of a single loop circuit. Okay, in a single loop circuit, all of the elements are in series. No? Vs is in series with R1, R1 is in series with R2, R2 is in series with R3, and R3 is in series with Vs. Because if you take a look at their points of interconnection, there's only one thing that is, there's nothing else that is connected. So how do we apply KVL here? Okay, if you apply KVL here, you're going to get Vs, okay, and then you have plus or minus VR1. Okay, why is this the polarity of VR1? That's because of the direction of current. Remember, no? Along the direction of current, you're going from a higher potential to a lower potential. So this is going to be VR2, and this is going to be VR3. So Vs plus VR1 plus VR2 plus VR3 is equal to 0. No? Now VR1 is I times R1, VR2 is I times R2, VR3 is I times R3. So I'm just going to get V of S, and I'm going to shortcut this. This is just equal to R1 plus R2 plus R3. Now, usually in circuit analysis, alam natin yung mga voltages and voltage sources and resistance values. So, so the usual unknown is the current. So I is just Vs over R1 plus R2 plus R3. Excuse me. Okay. So I'm okay. Ito naman Kirchhoff's current law. Okay. We can use Kirchhoff's current law to solve for the unknowns in a, so this is what we call a single loop circuit. This is what we call a single node circuit. Why you call it a single node circuit will be explained better later on, but actually there are two nodes here. No? There are actually two nodes. No? A and B. No? This is one node, and this is another node. No? But it is called a single node circuit. Sorry. It's called a single node circuit because you can only form one KCL equation. Because if you form KCL on node A or you perform KCL on node B, it's going to be the same. So if you do KCL on node A, you're going to get IT is equal to I1 plus I2 plus I3. Okay. But I1 is the voltage V over R1. So this is V over R1. This is V over R2. And this is V over R3. Okay, what is our unknown? No? Usually the unknown is V. No? What we know is the source. The source is a current source, which is IT. And the unknown is V. Okay, so if I solve for V, what am I going to get? IT is just V times 1 over R1 plus 1 over R2 plus 1 over R3. No? So, yeah, no? Let's call it G1 plus G2 plus G3. Okay. So that's the explanation here. Okay. What I have next are just examples. We don't have much time. I don't want to take. I promise not to extend much beyond an hour. No. So let me just go through very quickly how you might be able to solve this problem. So in this problem, you're supposed to solve for VR2 and Vx. Okay, so ito yung ano natin, VR2. How can I solve for VR2? Okay, I can apply KVL to this path. Right? So this path, no? Itong path na to. I know this voltage. I know this voltage, and therefore I should be able to compute for this voltage. Okay. How do I solve for Vx? Okay. Kung alam ko na yung VR2, I can solve for Vx by applying KVL to this path. Okay, now this is a very important concept. No? When I apply KVL, the path does not have to be physically closed. Importante ito, no? Kasi kita mo yung path ko, no? My path is from B to this, from here, up there, down here, no? So it's not physically closed. Path does not have to be physically closed, right? So this is what we call an open circuit voltage, the voltage between A and B, which is V of X. So I can apply KVL to that. Okay. Take a look at the succeeding slides. Okay, so try to solve this on your own. Ito, no? Now, the thing about this example is I have here what is called a controlled source. That is called a controlled source. This is a voltage source. Pag nakita niyo yung diamond, that is the standard symbol for a controlled source. This is a voltage source whose output voltage depends on some other quantity in the circuit. In this particular case, the voltage across this source is 2 times this particular voltage. Okay, so you can form a KVL equation here, and you should be able to determine the power absorbed in each element for the given circuit. No, we don't have time to do it anymore. No, again, this is also a controlled source. Okay, if you go through the notes, it's going to show you that there are 4 types of controlled sources. No? There is the voltage controlled voltage source. Actually, no, it's usually you call it voltage controlled voltage source, voltage controlled current source, current controlled voltage source, and current controlled current source. No? Those are the 4 types of controlled sources. And this is the symbol of your voltage controlled voltage source. No? This is the voltage controlled current source. This is the current controlled voltage source, and this is the current controlled current source. Okay, and then you have an example of a problem. So just go through it, no, because we lacked time. You now have an example of a problem where you have controlled sources, and then using KCL and KVL, you can determine the output voltage. Okay, sorry, is it output voltage? Yeah, no. Yeah, you can determine the output voltage of the particular circuit. So please, yeah, this is the last slide. No, I'm sorry I had to rush the last slides. So please go through the examples. I'm sorry if I was not able to discuss the examples in more detail. And if you have any questions, please feel free to consult me. So are there any questions with regard to this lecture? Okay, just some reminders, no. I think release na. I think the one in charge of the quiz for the first for this first week, I think already released the quiz. You can already take it in Uble, if I'm not mistaken. It should have been opened last night, and it will be open until Saturday. It's a 30-minute quiz, supposed to test you on what you learned in the first 2 lectures. Okay. Teka, may mga questions, no? Yes, no. This have answers, no. Yung mga examples have answers. Ito mga to wala yata, no. But if you tell me your answer, if you email me your answer, I can tell you whether you're correct or wrong. Ito at saka ito. Actually, these are very, very trivial. No? Ito yung mga tinatawag nating mga one-step solutions. That if you're really very familiar with the concepts, then you might even be able to do some of this mentally. Okay, what happens if some parts of the graph of a varying voltage goes below 0? What would be the V average? Okay. There's a question here, no? What if you had, I'm not sure if I understand the question correctly. What if I had a voltage like this, for example? V versus T. what will be the average voltage? Well, the average voltage is always with respect to time. No? So let's say T1, T2. The way you get average voltage is you get this area, which is positive, add it to this area, which is also positive, then subtract this area, which is negative. So this is let's say A1, A2, A3. So A1 minus A2 plus A3 over T2 minus T1, that is your average voltage. Okay. 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 Any other questions? Where could we possibly see the solutions of some examples? Also, how many items per quiz? I'm not sure how many items, no. But if you're familiar with the subject matter, it should not take you more than half an hour to solve, no. Yung half an hour, madami ng. And remember, open books, open notes. Just don't chat with each other while taking the quiz, no. Take the quiz independently, where we trust that you are honorable students, that you will not cheat, because it's very easy, for example, for you people to be taking the quiz simultaneously and conversing with each other while taking the quiz. Wag naman ganon, ano? If you really want to learn, you know that you shouldn't do that. Okay. Okay, so I guess that's it for module 1. So we'll see each other again on Tuesday. Again, if you have any questions, please feel free to get in touch with me by email, or you can post your questions in Uble. Okay, thank you.
Thank you, sir.
Thank you,
Welcome.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
sir.
Thank you po, sir.
Thank you, sir.
Thank you, sir.